Okay, today's lesson, lesson 21, is entitled Volume of Composite Solids. I think this is going to be a pretty short video because I'm just going to show you a couple examples. We'll probably quickly walk through several of them. Okay, I think this is pretty intuitive. I think you're going to figure it out. Okay, so volume of composite solids. So if you look at this shape here, it's the shape of a chest. We don't have a formula specifically for that, but if you can take a shape and break it up into parts, then you can determine the volume of those parts and then just add them together. So just the key idea is that there can be no overlap, right? So well, that doesn't look like no overlap. No overlap in our shapes. So this shape down here, we want to find the volume of it. We can see that the bottom part of it, this part here, is just a rectangular prism, and we know how to find the volume of that piece by multiplying length times width times height. So the part that we need to talk about then would be the part on top, this part here, which just sits on top of the rectangular prism, as far as we can tell. And that looks like a half cylinder. We're not specifically told that it is because we're not given this dimension, but I think we can assume this is a half cylinder. I would like a little bit more detail on this drawing. But given that, we're going to go with that. So we're asked to write an expression that can be used to find the volume. So in this part of the exercise, we're just going to write the expression. So the volume of the chest, I'll use something different. We'll go green here. So the volume of our chest here is equal to, we'll go color coded here. It's equal to the volume of the rectangular prism plus the volume of the half cylinder plus the volume of the half cylinder. Okay, so we get those two parts. So let's, now we can just begin to fill in the parts of our expression. So the volume of our rectangular prism is going to be 6 feet times 4 feet times 15.3 feet. And you can see that's going to be feet cubed because it's feet times feet times feet. And then the volume of the half cylinder, let's start with a factor of 1/2 out front. 1/2 of the volume that cylinder would be if it were a whole cylinder. Okay, so 1/2 of something. So we have to find the radius of this cylinder. Okay, so we know that its diameter, which is right here, is 4 feet. So since we're assuming this is a half cylinder, that this is indeed a circular arc here, the radius would be 2 feet. Okay, so R equals 2, and let me put it over here. R equals 2 right there. The radius is 2, so if that were a cylinder, it would be pi times the radius squared. Well, I'll just write 2 squared. Pi times 2 squared times the height of that cylinder. So the height of that cylinder, so remember our formula is pi r squared, or the area of the base, times the height. So the height of the cylinder would be this dimension right here between the bases. So that's 15.3 feet. Okay. And remember that this two squared is actually 2 feet squared. I forgot to write that in, but that's okay. I wrote all the other dimensions. Okay, so that, that is our expression that can be used to find the volume of the chest below. Okay, so in part B, we're asked to find the approximate volume of the chest rounded to the tenths place, and we're going to use 3.14 as an approximation for pi. So I've just recopied the expression that we came up with in part A, and so if we multiply these numbers out, we're going to get that the volume is approximately that. I took the 1/2 times the 4 and got a 2 right here. And 2 times 15.3 is 30.6 pi. So, so now we need to put in our approximation for pi. And that leads us to this, that the volume is approximately 367 2/10 plus 96.084. And finally, our approximate answer rounded off to the nearest tenth would be 463 3/10. Oh, not square feet. That would be cubic feet. Sorry, feet cubed there. Okay, so that's the basic idea of this entire lesson, is just that we can break these shapes up into their composite parts, find the volume, and then add them together. Okay, so here's a figure here that is supposed to be an ice cream cone, but doesn't look like any ice cream cone I've ever seen. It's got this scoop of ice cream perched on top of the cone. Looks like it's going to fall off. But anyway, we are going to find the volume of this figure. So this one's pretty straightforward to see that it's a sphere sitting on a cone. So we would write an expression for each part of that. Okay, so you should probably pause and try to do this one on your own, and then check back to check your work. Again, part A is going to be writing the expression, and part B is going to be evaluating the expression that we wrote. And again, we're going to have an exact answer in terms of pi and an approximate answer using 3.14. Okay, so let's look at it. So we can break this volume up. So the total volume is going to equal the volume of the sphere plus the volume of the cone. And, and so we need to write an expression for each of those individually. So the volume of the sphere, the radius of the sphere is 1 inch. So volume of a sphere is 4/3 pi times the radius cubed. And so that right there is our expression for the volume of the sphere. And then the cone is 1/3 pi times the area of the base of the cone times its height. So we've got, again, the radius of the cone is 1 inch. So we've got pi r, oh, that's not right. It's not cubed, it is squared. And so pi r squared for that, of course the value doesn't change really, but we should have it correct on there. Pi r squared plus, or not plus, but times the height, which is 3 inches. Okay, so there's those two expressions. And so we can simplify these somewhat. I'm going to do part B up in this space because there's room for it. So the volume 1 inch times 1 inch times 1 inch is just 1 inch cubed, or 1 cubic inch. So units on this are inches cubed. I'll go ahead and add that. So 4/3 pi inches cubed plus pi. Because if you look at this expression, the 1/3 times the 3 is just a factor of 1. So that gives us pi, and the units on that would also be inches cubed. So we've got 4/3 pi inches cubed plus pi inches cubed, and this is really 3/3, right? Because what I'm going to do now is add them together to get 7/3 pi, and the units, once again, are inches cubed. And and if I want to make that an approximate answer, I'm just going to put in 3.14 for pi and get 7.3 inches cubed for the total volume of that quote-unquote ice cream cone. Okay, our next example, exercise 3, is also very straightforward. So I'm just going to point you to the solutions, and then you can check the answer key for more detail if you need to. So this figure is pretty simply made up of a sphere sitting on a cylinder, which sits on a rectangular prism base. And we're asked to find the volume of the figure and write an expression, and then tell how much silver it's going to take to make this trophy. So that would be a volume of silver. So I'm going to point you to the teacher's notes for this example, and we'll move on to the next one. Okay, so our last example here is a long one, but it's all involves these 3 scoops. But I want to point your attention to this diagram. So we're going to use this diagram of 3 scoops, and then we're going to order the scoops from least to greatest in terms of volume. So we're going to be calculating the volume of the scoop. How much does it hold? So we can ignore the handles here, right? We just want to know how much these scoops hold. And all of the dimensions are in inches. Okay, so let's look at a couple things right off the bat. So we can't just look at these pictures to tell anything about these scoops, because you'll notice that this radius here is 1/2 inch, which means that this dimension across the top is 1 inch. And that's the same for all 3 scoops. The diameter across the top is 1 inch. The cylinder has this cylindrical scoop here, has a height of 1 inch. So you can see that that dimension there is out of proportion to the 1 inch across the top. So it should, probably be down here somewhere if it were a proportional drawing. It's not. We're going to use the labeled dimensions, and we've talked about this when you have geometric drawings in books. You need to always go by what the labels are, not what it looks like. Okay, whereas this 1/2 sphere scoop, if this is 1/2 inch, then this dimension is also 1/2 inch, right? Because it's also 0.5 in that direction, because it's a sphere. Sphere is equidistant from the center in all directions. All right, so this scoop is maybe smaller than it actually looks if you think about it. Okay, so I want you to just kind of maybe pause the video and study those diagrams and think about what are the shapes that we're working with here. What are we going to have to do to find their volume? And then to be able to rank them from least to greatest. Okay, I need a little space to work, so I've drawn some sketches of our scoops, and let's get going. So we'll find the volume of each one independently. The first one's a cylinder, the second is a 1/2 sphere, and then the third is a truncated cone, because the dimension of the bottom of the scoop is smaller than the dimension of the top. Okay, so let's start with the cylinder. The formula for this would be pi r squared, which is the area of the base, times the height. The height of 1 inch here, and so pi, the radius is 1/2 inch. Pi r squared times 1 and 1/2 times 1/2 is 1/4. So that volume ends up being 1/4 pi. So we're going to leave it like that and to make it easy to rank these. So 1/4 pi for that one. So let's look at the next one as a sphere. So the volume formula for that would be the 4/3 pi times the radius cubed. And we have 1/2 of that because we only have half of the sphere. Okay, so we've got 1/2 times that. Okay, so 1/2 cubed is 1/8. So I've put in 1/8 right here. And I've taken the fractions, the numeric fractions, pulled them out front. So we've got 1/2 times 4/3 times 1/8. So we can do a little bit of simplifying before we move on. So this, take that factor of 4 out and we get 2 down below. Let me see if I can write that. Okay. And so this becomes 1/12 pi. So we've got 2 times 3 times 2 in the denominators there. So it's 1/12 pi. All right, so on the truncated cone, I've drawn some, I've completed the cone here. So the cone is completed, so we've got this dimension here. We need to find what would have been the height of this cone if it were extended out. Okay, so my drawing's a little out of scale, but that's okay. You can get the basic idea. So remember, we write those ratios. So we've got 0.5 being the radius of the large base, and then 0.375 being the radius of the smaller base. And then x plus 1 is the height of the large cone, and x is the height of the small cone, the part that's lopped off here. Okay, so we've got this ratio, and so we can look at the cross products here and here and set them equal. So that's what I've done in this part of the equation here. Now I'm going to subtract, oh, that should be a 7 right there. I'm going to subtract off 0.375x. And when I do that, this term drops out, and this becomes 0.125x is 0.375. And then dividing, I get x equal to 3. Okay, so what we know is that this dimension here, the missing part, is 3 inches, and this part was 1. So the total height, so we've got this large cone with a total height of 4 right here. 1 plus 3. Completely out of scale, but don't get bothered by that, okay? It's just my drawing. So we've got 1 plus 3, 4 for the height of the large cone, and 3 for the height of the small cone. All right, so I'm going to come over here, and this would be 1/3 pi times the radius squared times the height. Okay, so this is the volume of the large cone before anything was taken off. Okay, and I'm going to subtract off the volume of the small cone. So the volume of the small cone is this part that is missing. All right, and then if I subtract those, I'm going to get just the volume of the scoop. So there's the expressions for those two cones. So it's the entire thing minus the part that's lopped off, and we get 1/3 pi for this first part, because 1/2 squared is 1/4. So 1/4 times 4 is just a factor of 1. So this whole thing simplifies down to 1/3 pi right here. This expression is a little more complicated, but it simplifies to 9/64 pi. So if I get a common denominator and subtract those, I get 37/192 pi inches cubed for the volume of the truncated cone scoop. All right, let's get a new page here. And so there's those expressions. I had 1/4 pi. This was the cylinder. 1/12 pi was the sphere, and 37/192 pi is the truncated cone. All right, so let's put those with a common denominator just so it's really clear what we're comparing here. So we can see that the sphere is the smallest here, 16/192. The truncated cone is in the middle, and the cylinder is the largest scoop. Okay, this next part asks us to figure out how many of each scoop would be needed to measure out a ½ cup of sugar to a cupcake mixture. Okay, so we're told 1/2 cup is approximately 7 cubic inches. So 7 cubic inches in a 1/2 cup. So what we're going to need to do, and I'm going to do the example for the cylinder. Get a better color here. So I'm going to do this example for the cylinder. And the cylinder scoop, the volume was 1/4 pi. Okay, so that is approximately, and that's inches cubed. So 1/4 pi is approximately 0.785 inches cubed. Okay, this was inches cubed. All right, so our cylinder scoop has that volume. So what I need to do to find out how many of those would make 7 cubic inches is I'm going to take and I'm going to say 0.785 times some multiplier is equal to 7 cubic inches. Okay, and once I have that equation, I know what I'm to do, right? So let's see why this makes sense. This is the volume of 1 scoop in the cylinder scoop. Multiply it by some number. You know, if I had 2 scoops, then it would be 2 times this. If I had 3, it would be 3 times this. So how many of these are in that? So that's what this equation is doing for us. So at the next step, this is going to look like x is 7 divided 0.0785. These are calculator problems, friends. So make sure you do this on your calculator. And we're rounding to the nearest whole number of scoops in there. So the number of scoops for the cylinder is approximately 9 scoops. Which makes sense, right? If I had 10 scoops of this, I would have, multiply by 10, I would get 7.85. That would be almost 8 cubic inches. So I can see that 10 would be too big. And so 9 is the nearest whole number of scoops. So, I hate it when I see these spelling errors. So you can work that out for the other two and check your answers. The spherical scoop, I would need 3 times. I would need 27 scoops to make a ½ cup, and for the truncated cone, I would need 12 scoops. Okay, there you have it, folks. So when you have these figures that are composites of others, like this one here, what you want to do is break it up and find the volume separately. Okay, so this gives you a lot of practice with your number sense and with writing expressions and so on. So good luck on the problem set for this. And our last lesson that we're going to do together is going to be lesson 22, and it's kind of a change of pace, but a fun one. So I'll see you back here tomorrow for that.